Hello there. My name is Brooke Solomon, and today I'm gonna try to solve one of the problems from Lead Code. Hopefully, not too hard or not too easy. And a little about me. I am a second year software engineering student. My passions revolve around data structures, data science, and algorithms. This is part of why currently about to embark in solving one of these questions, and I find this to be my passion because it allows me to engage my creativity and my intuition into something that's practical and helpful. So we'll just go over and pick one. We'll see if it's too easy. Hopefully, we'll be in the medium section. Okay. So it's loading. So it says longest substring without repeating characters. It says it's a medium question. Let's give it a shot. Given a string, find the length of the longest substring without repeating characters. So seems like a maybe easy question. Let's give it a look. So A, B, C in this case, because A comes around here. Right here there's an A, so this would be a repeating character with this one. So again with B, this wouldn't work. So the longest substring would either be this one or this one right here. So the length would be the only thing we return. So in this case, the longest would be A and 1. So B, 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 B. In this case, the longest would be KEW. So in this case, the longest is as such, and must be a substring. It has to be a contiguous one line. It can't go from here all over here. It has to be one contiguous sequence, a substring, not a subsequence, basically. So what I'm thinking with this one is, for example, let this be a comment. Looking at the string A, B, C, A, B, C, B, B. So what I'm thinking is we have 2 pointers, each one starting here, and once we go one forward, we keep track of the count, which is the maximum length we have right now, which is 1. We check, no repetition, so we move 1 forward, no repetition, so this increases. We can keep storing them into a set to determine whether they're repeating or not. It's approximately 01, so especially the length of the string or no other constraints are given, so we can stick with this. So once we add this one, basically increasing it by 1. Sorry, this was 3 in this case, because once this was here, the difference would be 3 because there are 3 letters around it. So once we go above, we see when we try to add this element into the set, this A right there, we see that it's already in the set, so we'd push this 1 more and keep the count the same. So basically what we're doing here is we're removing this element from the set. So we check again, and this time we can add this one, so the count is set to 3 again. So we increment it by 1, and basically we check again. Turns out, nope, it's already in the set, this element right here, in this element, so we can't add this element inside. So what we do here is we increase it by 1, technically just taking this element out of the set, and we check again, and yes, we can add it. So the count is still 3, we add it by 1. Same thing with C again. So we do this, we add it again by 1, we realize there's a B here, so we add by 1. We still haven't found room for this, so we still keep adding by 1. Now we have room for it, and now when we add 1, the count in this case would be 2. So in this case, when it tries to add this one, it realizes it's already in the set, so what it does is it increments again, then it's still in the set, so increments. So this case would work. So this is 1. When it tries to go, it's above the limit, so in this case it would return the maximum count it has, which is 3. So in this case we need 2 pointers. We can call that the starting from 0, so my bad, and also the end. So basically what we want to do is we want to keep this happening until end exceeds the length of our string. And we also need a set, which is, we can call those the substring, basically representing the substring using a set. So what we want to do is, first of all, we add the end element inside our set. So what we want to do is dot add the end element, meaning s end. Then actually we want to check if it's already inside before we add it. So if end in our substring. If it is not in our substring, this would what happen, and end would increase by 1. And okay, we didn't have the max count, so we can call this the max count, currently at 0. So basically what it does is it's start max count would be equals to max of the current max count and start minus end, because we want to add that number inside after we moved 1 forward. So max minus end would work. No need for a +1, I think. So in this case, we need to keep moving our start pointer and keep removing items from the start until we find out that this character right here is not in our substring list. So what we do here is we basically set dot remove. I'm thinking that this actually exists. Yeah, it's remove. So set dot remove. Oh, sorry, it's our substring. Dot remove our start character, and basically we keep incrementing start by 1. Basically, at some point it will get to a point where this is removed, even though it has to, in this case, it would have to come on the same location. Once before, when you had it this way, it would have to come to the same location, but that's okay. So basically, start minus end would be our max count. So this goes on and on and on until we can get to the end of our list, end of our string. Then we want to return the max count, the one we've been keeping. So the only, okay, again with this one, substring. So we have a start pointer and an end pointer and a max count, which is counting the maximum, and we have the substring. Then what we want to do with the start pointer is it tells us where to remove from our list, from our set, basically from our substring. So once we were here in the previous iteration, once we get to here, we see that this element is indeed inside the substring, which is this clause right here, this while clause. So while that is the case, it removes this, then realizes, okay, we removed the start, the first start, which is the A. So now it's not inside our set. So this while loop would be complete and it would go over here. So this seems like it would work. So yeah, it adds it and adds 1. I think this would work. Let's give it a shot. Okay, wrong answer. While end is less than max count is start minus end in substring move dot start. Okay, max count is the maximum start and minus end. How about after each iteration we print out our substring and our start and end and let's give it a shot again. Substring A, start 1 0, start 1 0. Actually, oh okay, my bad. Right here, it's end minus start. Trivial mistake, my bad. So in this case, BCA and start. So this seems to work. Let's give it a shot again. So in this case, it does work indeed. So this is what it's considering, 0 to 3, which is these three right here. So yeah, let's think of some edge cases. For example, when the whole thing is unique, since it would not have to get into this while loop at all, I think I'd like to give that a shot. Okay, let's return the length of the string. Okay, yeah, it does. So the next one would be when each element is repeated. So I think it has an example of that. There we go. Let's give that a shot. Oh, okay. This does work. I realized I forgot to mention something about the time and space complexity. So if we time complexity in this case, since we are discussing about moving two pointers, each pointer will make exactly one pass. So we make two passes along this entire string itself. So this would take order of n. As for space complexity, we are only keeping track of the substring at a time. So in the worst case scenario, which is the previous example we discussed, the space complexity would be O of n. Oh, my bad. O of n. Aside from that, I think it does seem to think that this might be an edge case because we can't skip over like this one, but my algorithm wouldn't think of it. So, but let's give it a shot. Let's send this one over. And yeah, since we have not been given basically any constraints, I want to try what would happen on an empty string. So yeah, there's a possibility it could have given us an empty string and the answer would be 0, which makes sense. So in this case, since it's on, I don't think we have to try any extreme cases where it's a big number. I think we'd be okay with submitting it at this point. Okay, output limit exceeded. My bad. I forgot to take this one out. So this is my bad. But since we already have the test case right here, we could give it a shot. But oh my god. Okay, it's a long one. So yeah, we could just take this one in and run the code with it. It should not hit the time limit exceeded. The output limit exceeded was because of my print statement I put in. And here we would have accepted, yeah. No time limit exceeded. This was my mistake. So yeah, this seems to be a functioning solution. I guess in the question of could we make it better? Since we'd have to check against all of them, I think the set is a necessary entity. I don't think we can remove the set. But I think there are no limitation on what the character should be, right? Okay, yeah. So at most, it could be every single possible character. So yeah, currently no way of improving it comes to mind in regards to time and space complexity. But yeah, order of n is the best I could do in this case. Thank you for watching, thank you for listening, and this is Brooke signing out.